Don't do this. Building a string with the plus operator just so that you can use print is a pretty awful thing to do on an Arduino, particularly on a small Arduino like an Uno, but it doesn't really become a good idea even on larger Arduino target like an ESP32. I won't tell you that I never do this, but I'm not in the habit of doing it, and you shouldn't be either. If nothing else, what I want you to take away from this is that this code is better. Uglier, maybe, but better. And if you don't already know why, you will shortly. 3 quick notes. I don't generally endorse the use of float, particularly on an Arduino, but that's a topic for another video. This particular example will be familiar in any case. I'm not using the F macro in these examples, not because it isn't a good idea, it is, but because it has nothing to do with what I'm trying to explain, which makes it noise. Everything I'm saying applies to anything that supports print and println, not just serial, but libraries for SD card file access, liquid crystal displays, and so on. So why? Why would you choose this over this? Simply put, this one is lighter weight and is also more stable in part because of that. This code dynamically allocates memory. Worse, it does it repeatedly. When I say dynamic memory, I'm referring to the heap, as in malloc or new. The Arduino people have hijacked this term to mean something completely different. So when you compile in the IDE and you see a summary at the end that says dynamic memory, that's referring to something that has nothing to do with actual dynamic memory, the way the term is used everywhere that isn't Arduino. It allocates once when the string is created, and then it allocates twice for the 2 plus operators. The actual story is a little worse, with 4 allocations, but I'm not going to try and bother to explain why that is. What's more important is the second example doesn't dynamically allocate at all. I'm not going to make this video about the potential pitfalls of dynamic allocation, nor am I going to go into some spectacularly bad handling of it that can be found in the Arduino libraries and even in Arduino board cores. For the purposes of this video, it's sufficient to say that dynamic allocation makes your code more brittle at runtime, and often fails in ways that lead to long, frustrating debugging sessions. This particular use case isn't as bad as it could be. Most of the time, as you add things to the string, it will just expand the existing allocated area, and then it will free that memory before moving on to do something else. It's worse when you concatenate to a string variable a bit at a time, not all on one line, while calling other code that also does dynamic allocation. Then you can get into something called heap fragmentation. But there's no good reason why dynamic memory should be involved in this code at all. In the latter code, there is no dynamic memory allocation. The former code constructs an entire in-memory copy of the text, including a rendering of a number as text, concatenated together. So you must have enough memory to represent an entire copy of everything that you're about to print. There are reasons to build strings in memory. Doing that just so that you can print or println is not one of them. Here it is being done for no good reason. In the latter code, there is no point at which your entire concatenated message necessarily exists together in memory as a string. There's no need for it to. It just sends the parts, one at a time, in the correct order. The print and println functions can't help but concatenate things for you. That's what they do. So why would you do it yourself first? Only in a crappier way. Writing to serial has fairly stable resource requirements. If the stream is buffered, and if that buffer is full, print will just wait until there's space. If printing managed to fail somehow, there would be a fairly simple reason that you often can't, or in some cases shouldn't, do anything about anyway. Something like a USB cable being disconnected, or an SD card filling up. They are causes that tend to be fairly easy to reason about and find when you're debugging. The generated code to build a string in memory through allocations and reallocations and copying is simply larger than the 3 print statements. No kidding, your generated code will actually be smaller and less complex if you just break it up into 3 calls to print. Just because the text of your source code is smaller doesn't mean your generated code is smaller or better. To give you a sense of the difference between these methods, I've tested both methods separately in a common test setup. I'm not reading a temperature sensor, I'm just putting a number, namely pi, that's what the arc cosine of -1 is, into the temperature reading variable. So it's a rather frigid simulated 3.14156 or so degrees C now, just a little above freezing. The temperature reading variable T has been volatile qualified so that the compiler won't optimize it in a way that it could not have done if we were really reading a BME 280 or a DS 18B20 or some other temperature sensor. This code was compiled with the Arduino AVR Core version 1.8.6 with compiler and linker options including optimization parameters very similar but not identical to those for an Arduino Uno. I used a simulator so that I could configure it such that the simulated serial character transmission takes no time to speak of, making the effective baud rate ridiculously high. So you can ignore the 9600 here. In real hardware, probably at most baud rates, the number of cycles used in both of these methods would be almost the same. Because in both methods, cycles not wasted in concatenating and heap allocation would have been spent waiting for the serial hardware to finish sending characters. However, if you do enough of this concatenation and allocation of string variables, you'll eventually start actually slowing down your real-world serial throughput. Because there's effectively no waiting for serial in this test, the cycle counts are closer to a measure of the complexity of the code being generated and executed between the two methods. In other words, the difference in cycle counts gives you some idea how much more unnecessary junk is being generated and run in order to do the same job. And that's what I'm interested in showing. And here are the results. Switching to just the 3 print and println function calls removed 1,316 bytes of code, which is significant. That's code you didn't need to generate. It's possible that some of the code bloat would be amortized, reused, basically, by writing more of this bad code, but I haven't tested that, though I suspect it doesn't change much. And it's spending something like 1,562 cycles running that code. Again, on a real chip, we're largely I/O bound, that is, mostly waiting for serial. So this is really just indicating that it's running a bunch of unnecessary code, though perhaps at some baud rates you would actually see serial throughput go down because of these extra cycles. So this is not an extremely scientific test, but I hope it does give you some idea the difference between the two methods. What isn't measured here is just how much of a pain it is to have dynamic allocation fail on you and produce a debugging nightmare. I'm not sure how I would measure that, but there's no need to invite that situation by writing inferior code. As you choose larger microcontroller systems, this is less of a problem, but there's no point at which available memory makes concatenating a string like this a good idea. It's more of a problem on an Uno than an ESP8266, for example. However, there's a sort of fishbowl effect at play here. I've seen people build large web pages inside single strings on ESP8266 boards. In any case, calling print multiple times will pretty much always be better. If you think the multiple print and println function calls look uglier than using the plus operator, well, okay. Although, once you understand what is happening in the allocation and concatenation code, it's difficult to not see some kind of beauty in the comparative simplicity of the multiple print calls. There are some things you can do about this ugliness. However, most, if not all of them, introduce more junk into your code to maintain. That's more stuff that people, perhaps future you, have to find and understand in order to make sense of your use of it. Sometimes it's worth it, sometimes it's not. So I'd encourage you to consider, in any given case, whether or not multiple calls to print and println isn't simply the correct thing to do. There are things you can do with functions, macros, references, and function templates that carry varying degrees of technical debt in pursuit of making the code prettier. If I tried to cram all the ones I know into this video and talked about them, I would bore most of you to tears. But know that there are ways to make the code look nice without resorting to string and its plus operator. The main thing I want to get across to you is don't do this. Do this instead. Or at least prefer this. This, not this. If you found that helpful or informative or entertaining, let me know, so I know whether or not to try to make more like this.